Hi, everyone. So as John mentioned, I work at vCluster. We are a company behind containerized Kubernetes, and we like Kubernetes so much that we put Kubernetes inside of Kubernetes. And you will see how cool is that later. The topic of my talk will be flexible multi-tenancy. And I would like to start with a kind of a promise, and hopefully at the end, you will see that what I promise makes sense. And I say that multi-tenancy nowadays is becoming slowly table stakes. Like in the old days, having a server was table stakes, or then having a domain and web page. Then slowly we are moving to a world where supporting multiple internal customers, maybe your teams or external customers, maybe you're serving a SaaS or other products, is really critical. So this will be the topic of the talk. A little bit about me. My name is Piotr Zdaniewski. I work at vCluster as a head of engineering enablement. This is really platform engineering. We just thought that this name is more fancy. But I do operations predominantly in platform engineering. I've been running platform teams and been in the space for quite a while. I worked at Abound before, creators of Crossplane, and I've worked at Kubernetes in various areas. I like GitOps. I worked as a SRE, so all that stuff. Been there, done that, and still enjoy the space. I do speaking engagements. You can snap this QR code, and this will take you to my webpage where you can follow me on social media if you'd like, or just check out my other content. In my free time, I like working with NeoVim plugins. So if any of you like NeoVim, I have quite a lot of plugins I wrote and also videos about it. So yes, I am a NeoVim nerd. Lately, I started writing MCP servers for fun. Some of them became a little bit popular, so you can check out my GitHub profile if you're interested in this. All right, so what is tenancy or multi-tenancy? If you think about Kubernetes, I believe that it's nice to think of tenancy as a house. We all know a house. We either have one or more, and we live there. So if you live in a house or in an apartment, you definitely have neighbors. Hopefully, your neighbors are quiet, but not all the neighbors are quiet. So a single Kubernetes cluster, if you have teams or customers that run in the same cluster, that workloads run in the same cluster, it can be noisy, right? And in Kubernetes, this actually can lead to security problems, can lead to performance issues. So simply, there is a scenario where isolation is not really a first class citizen in Kubernetes. There is a mechanism in Kubernetes that you probably know if you've worked with it, called namespace. So namespaces is this basic mode where every team can have their own dedicated namespace and they can run their own workloads. But as we will see later, this has its own limitations. So this, courtesy of ChatGPT, obviously, picture shows us that the typical way of isolating workloads within Kubernetes is multi-tenancy, but we can do better. Now, is it really better? It depends how you look at it, but that's definitely how you can think of vCluster and its multi-tenancy. So suddenly, instead of having namespaces isolated just in this weak isolation level within your host cluster, you can actually have little Kubernetes clusters running within pods. So each of those windows represent a pod, and this big house is a host cluster. So that comes with all kinds of benefits. Isolation is immediately much better, and tenants don't actually interrupt each other and can still use all kinds of plumbing or electricity at the house. However, some of the tenants might have different needs than the others. Some of them might want more power or more privileges than the others, and we as platform teams or SREs might decide to do it. So we end up with this. This looks like a jumbled mess, but reality often is. And this actually shows us that every tenant can have and usually does have different needs. If you have supported your own teams within the Kubernetes cluster, you definitely will remember that maybe team starts on tier A of your internal platform, and then after a while they want something more. Some other team comes and they want a slight variation of what team A has, and it's never exactly a cookie cutter within the tenancy world. So we end up with scenarios where some of the tenants would use services that exist on the cluster. We call them shared services. Some of them would have their own plumbing with them. This picture doesn't really show it well, but imagine that you have water or electricity appliances on your own in your little home. So this messy reality is actually what we deal with. And vCluster is uniquely positioned to actually exactly work with this reality rather than with the cookie cutter marketing material where you have exact 10% this, 20% that. So how it works in practice, what vCluster really does. So the easiest thing to explain vCluster is that vCluster is a containerized Kubernetes inside the pod. Why on earth would anyone do it, right? So pods are the smallest deployable units within Kubernetes, and pod can run any number of containers. So vCluster takes advantage of this, and what we did is we took Kubernetes control plane. So if you're familiar with Kubernetes, this will be Kube API server, scheduler, and so on. And we placed those control plane elements, the control plane machinery, inside of a pod. And that gives us all kinds of interesting properties and benefits. We will dive into this a little bit later, but I want to show you what we can do. If you imagine Kubernetes from the perspective of the host cluster administrator, let's imagine that you are an EKS, working with EKS or GKE or Azure or on-prem. So you have a big host cluster, and within this host cluster, you might have several nodes, and then whether those are internal teams or external customers, they use your Kubernetes resources in various ways. Very often, as admins or platform engineers, we would have set of shared services. Think about cert manager, ingress controller, API gateway, service meshes like Istio, Falco for security, you name it. There's plenty of CNCF landscape projects we've all seen that you can install. Those shared services often require complicated configuration and maintenance. But what vCluster enables us to do, it enables us to create virtual clusters that either take those services and being themselves a completely isolated Kubernetes cluster can still use some of those shared services, or we can decide to actually place those shared services inside of vCluster, and then they become services unique to this virtual cluster that we elected to do. The obvious benefit from this is, of course, isolation and security, but also versioning. I can have ingress controller or API gateway version different on my host cluster and different in virtual cluster. So suddenly deploying of global resources is possible inside of virtual cluster. But if you haven't worked with virtual clusters, it might be a little bit confusing. So I'm going to try and show you and demystify a little bit how all this works and what can you do with it. So one more time, virtual cluster is a fully certified Kubernetes distribution. So like any other Kubernetes distribution that you can install anywhere, virtual cluster has all the components of Kubernetes, just with the difference that they are inside of a pod. Virtual cluster itself is quite small. It's very resource efficient. It's about 400 megabytes pod, and you can run them really easily, and you can have multiple of those, as we will see in a moment. All right, so we are going to use kind cluster. I cannot see all of you, but typically I would ask how many of you know kind cluster. If you don't, it is a really easy way to run Kubernetes locally, kind cluster stands for Kubernetes in Docker. So nowadays, everybody has Docker. If you have Docker installed locally, you can super easily run Kubernetes on it. So that's what I did. I already created this kind cluster before. So once this kind cluster is deployed, we're going to proceed with the demo, but I want to stop and talk about another layer of multi-tenancy. So we talked about services isolation previously, so where we said that some services from the host cluster can be reused. Some of them can be dedicated to a specific team or a customer. The same can be said about security boundaries. Nowadays, I think it's extremely important to take security even more serious than we used to take, partially because of AI and more code coming our way, and this code is not always clean or high level. So having an ability to decide whether a certain team or workload has a high trust, zero trust, partial trust is very useful for platform teams. So we can dedicate certain zones within our host cluster where we can host or accommodate tenants that we assign to one of those security zones or isolation. So this is just another slider we can think about when we apply multi-tenancy in the real world. Earlier, we talked about shared services versus isolation, and then we have another slider which gives us the ability to trust or not trust certain tenants or workloads within the tenant. So let's see what we're working with. I have here 2 nodes, and I just labeled them for the purposes of the demo. So we have 132 Kubernetes cluster running within my kind cluster, and this all works on my computer. Let's hope the demo will be quite okay. I want to install Nginx, and I will show you what's happening within the cluster. So I'm going to swap quickly to a different terminal, write K9s. Again, if you know K9s, then you know it is awesome. If you don't and you work with Kubernetes, I highly recommend this program. As you see, it is a terminal-based Kubernetes viewer. You can interact with your cluster, and I'm going to use it to show you what's happening. So nothing interesting here. We just installed Nginx controller. That will be useful for our demo later. For now, we have our kind cluster called vCluster Multi-Tenancy, and we have a typical resources here. It's a fresh cluster, haven't done anything with it yet. All right, so this is done. Let's talk more specifically about the challenges that come from using namespaces. If you're using namespaces, what namespace is essentially a weak isolation boundary within Kubernetes that allows you to segregate resources into the namespaces. Things like pods, services, and other base Kubernetes resources can be namespace based. And this works in many cases. It's very quick to create a namespace and it's very fast to spin up one or delete. However, it comes with a lot of limitations. First of all, we have a shared API server. So everyone connecting to our namespace connects to the same Kubernetes API server and shares the same underlying data. Thus, the separation here already is weaker. This brings shared control plane risk. If control plane goes down, it goes down for everybody. And if control plane is corrupted for everybody. Another important limitation of namespaces, which if you work with Kubernetes, you definitely stumbled upon it, is the fact that namespaces do not support global objects such as CRDs. So if team A wants to have a different Istio version than team B, this is simply not possible with namespaces. And thus we fall into this trap of version locking. Now, one caveat here I want to make is that namespaces are not evil, far from it. They are very good tool if you just want to isolate workloads. If you're isolating pods and you have teams that only separate workloads and you don't need anything else, fantastic. That's a great solution. However, in reality, as we've learned at the beginning, reality is messy, and then you will quickly stumble upon a problem where the teams want a little bit more, a little bit extra. So if teams want a little bit extra, what can we do? Enter vCluster. So what we are doing here, I'm going to let it run first, and we're going to talk through what's happening. So here, every vCluster supports YAML file with values. This is simply a Helm values pulled into a YAML version. Almost any resource in Kubernetes, as well as kind, by the way, supports configuration from YAML. So we follow the same principle in vCluster, and we use vCluster CLI to create a dedicated virtual cluster. So the virtual cluster we created is named dev team. We do not connect to it at the start, and we are using this dev values file to instruct the vCluster operator within our pod how we would like our virtual cluster to work. So let's swap real quick to our K9S, and you can see in the background here, we have a new pod. Notice that vCluster is actually pod. All of those resources here are pods. So this is not a CRD-based controller. It's actually a normal pod. And this comes with all kinds of benefits because you can treat it as any other pod in Kubernetes, meaning that your existing security posture, your existing observability tooling would work with any vCluster. So we have core DNS, which comes as part of virtual cluster, and we have the virtual cluster name we created ourselves. There's this little -0, and I cannot see you and chat, so usually I ask this question, why this is -0, and you can take a moment to think about it, but -0 simply is a stateful set. So vCluster by default comes in a form of stateful set and creates just those two pods on the disk. Okay, so far I hope it's pretty easy. We've created a pod. Now let's connect to this pod. So before we connect, I actually want to talk a little bit about why would we choose vCluster for multi-tenancy. So what does vCluster offer that is so good within multi-tenancy that we would like to consider it? So vCluster spans various areas, so to say. So we can focus on development, and if we have dev test environments, we can fully isolate them, which is really desirable. If you run Kubernetes in CI, you can spin multiple virtual clusters really quickly on your dedicated cluster, and then just have your CI target those rather than create clusters ad hoc. In production, you can have resource quotas or separate services. There is also significantly more isolation than I am showing you now. I am focusing only on the open source virtual cluster. We have recently released quite a few exciting offerings for multi-tenancy specifically, such as private nodes and others. I'll be happy to chat about it later if you would like to dive deeper. But suffice to say, this moves us further towards isolated clusters. So think of almost having almost like a separate cluster where each virtual cluster can target its own set of nodes. We have data science capabilities. So if you're familiar with KAI scheduler from NVIDIA, vCluster can run those workloads as well, and you can isolate AI inference or training time through this mechanism as well. And this is what a lot of our customers do as well. So think of providing a GPU capability to your customers and having vCluster as a foundational technology for multi-tenancy. And finally, you can also expose parts of your Kubernetes resources to third parties or external partners like consultants maybe, or you have security audit or compliance. And we will see this in a moment as well. So let's connect to our cluster. So what's happening now, I am doing this locally. So vCluster is creating a proxy, enabling me to connect to my Kubernetes cluster. So let's see how this works. When we swap back, I'm going to restart K9S. You will notice that now we are in different virtual cluster. So we are here. Previously, we were in the kind cluster, and now we are in this long name context and long name cluster. So the pod that we have seen earlier with this dev team -0 has its own Kube API running. And you can see here, we have this core DNS pod. So now I am connected to my virtual cluster. And from my perspective, as a customer or a team member that we support, this looks like regular cluster. I don't see any other pods or any other resources for the matter that are running downstream on my host cluster. I just see what my Kube API server shows me. So this level of isolation means that I can interact with this cluster as if it were a regular Kubernetes cluster running in cloud or on-prem. So this is the level of isolation we are definitely after. So let's look what the vCluster pod has inside. So it has one init container, and you can see this is 134 Kubernetes, although our kind cluster is running 132. This is an interesting distinction for virtual cluster. We can run different Kubernetes versions in each virtual cluster. There's a skew of versions supported, but we can upgrade and downgrade versions as we see fit for each tenant individually. So we have this init container that copied all the Kubernetes machinery, and we have a special container that we call Syncer. Syncer is responsible for synchronizing resources between our virtual cluster and host cluster. What does it mean? Why does it synchronize anything? So you can see here that by default, virtual cluster keeps its resources inside of a database. In an open source virtual cluster, if you create one, go to our repository, install Helm chart, by default, you will get a SQLite, and the SQLite runs inside of a pod. So I mentioned earlier, we have API server, we have controller manager, we can have optionally scheduler, and we have our database. So this means that we have completely isolated little cluster that we can take, move around, and we can choose to synchronize various things between the host cluster it's running on and itself. So if this is possible, then this means we should be able to deploy something to it, right? So what I did is I deployed a web app. This is a super simple Nginx web app. And notice that we just did the deployment, we run it, it's done. And this deployment is running on our virtual cluster. So just to prove it to you, you can see now we have the web app here. This was previously not there. We are still connected to our virtual cluster. And if everything goes right and demo gods are with me, if I hit enter, this will work. Let's see. Okay, we are port forwarding. There you go. Kubernetes demo. We have a curl here. Let's see if we can open it in the browser. And this is a beautiful aggressive green, as I like to call it. So this works. This is fantastic. Okay. We were able to deploy a regular web app inside of a Kubernetes, inside of a Kubernetes. But this just goes to prove a point that this is regular Kubernetes cluster. Nothing different about it. It's just that from the perspective of my tenant, this just works, right? Okay, I mentioned earlier that our virtual cluster is fully encapsulated. And I want to show you that we can actually take it from our current host cluster. Remember, this is a kind cluster I'm running now. What I'm doing now is I'm snapshotting vCluster with its current state. If you don't know the service, TTL-SH, it's a super cool service that allows you to share OCI compliant artifacts like Docker images for free in an ephemeral way. So we have this little image that will expire within an hour. We snapshotted it, we send it to the internet, everything is great. Now we are going to create secondary kind cluster. We are emulating at this point that we maybe want to take our virtual cluster with all the data, with all the running state, and we want to clone it and transition it somewhere to maybe AKS or GKE or on-prem, right? It can be cloned and the old cluster can be deleted, or the cluster can be simply copied. All right, so let's create it. So you can see now I am creating the same cluster called dev-team. In this time, I'm using a restore flag, and I'm pointing to the same image in the TTL SH service. So let's see if we are still lucky and our cluster works. Let me restart K9S. And if we are lucky, we are on kind host 2. We are. Today, it just works. Must be the conference. Fantastic. So we have kind host 2. And notice that our dev team vCluster is starting to be created. We have a special process that initializes the old settings and is essentially under the hood restoring the database and is reinitializing our dev team cluster 0. So this experience should be the same as we've had at the very beginning, where we created the virtual cluster first place. The difference is that now we are in a completely new host cluster. I probably should have named it like kind EKS and kind AKS, but that simulates this scenario. So now, finally, you can see we have our web app. It's right here. If this web app would have stayed with persistent volume, we could also choose to clone persistent volumes as well and to move them from one place to the other. Some of those things are enterprise features, some of those things are open source, but snapshotting vCluster like this is available for free as well. So you can take advantage of it. So once this is done and the container is going to be created, we should be able to interact with our web page in the same way like we did earlier. Let's see if this actually works. So this might take a moment because I've seen that the container is still created, but let's give it a try. Oh, we have to wait a little bit longer. Starting, forwarding, there we go. You can believe me that the same page is rendered now in completely different cluster. So that shows the power of what you can do with your virtual clusters. You can just take it from one host cluster and put it to another one. So let's delete this so my machine actually doesn't die in the meantime. So now this was kind of like a warm-up, and we are going to create another virtual cluster, this time for production. I'm going to go through this a little bit quicker due to time, but this just goes to show that now we can create a virtual cluster with different properties. So in this case, we are actually telling virtual cluster, create an ingress, so synchronize ingresses from virtual cluster to host, and synchronize nodes from host. I'm going to explain all the settings. Our docs guide you through all the possible settings. There's quite a lot of them. So you can realize the promise that we talked about at the beginning, that you can actually slide the multi-tenancy sliders however you see fit. So this worked. Let's connect to our prod team. I'm going to swap real quick here. And as you can see, vCluster prod team. So we are now in another virtual cluster in the previous host cluster. This is, by the way, something you have to get used to or pay attention to, because it's a lot of swapping between clusters. If you're an administrator, you should better have your prompt annotated with what cluster you're currently on. Right, so we connected to it, and we are able to, in this case, I'm just showing you that we can actually expose the web app on our current DNS, and we can also see the actual node IP. You have to believe me that this is true because we can actually expose it to production team. Normally, this due to security settings, we do not expose the actual node IP to virtual cluster. And finally, a last quick demo with a feature that I really like. Imagine that you are a partner that collaborates with, or a partner company collaborates with your team, and you want to give them just a very limited access to your resources, but you still want to be able to onboard them to your Kubernetes cluster. And virtual cluster comes in handy. What we are doing here, we are saying every new virtual cluster created from this partner values file will have a config map and a secret. So you are using a templating system to create your virtual clusters with the special applications. This can, of course, be extended significantly. We have a dedicated templating system with permissions and application that helps you manage those things. But for the easy demo, we can definitely do this like that. So we're gonna give it a moment to create and stabilize. And if everything is correct, we should be able to see this config map and secret when we connect to the partner team cluster. And we have a platform config and we have a platform credentials secret. Let's see if this actually is here and I am not lying to you. So here we have a secret, platform credentials. And for those of you who are already excited about K9S, you can click X to decode our token. And I just leaked a token, partner ready token. There you go. Okay. So of course it's a test token. I didn't really leak it. All right. So now we have all those different clusters that we've created. And as a platform team or SREs, we were able to cater to various needs of various teams. So what were those needs? Let's summarize real quick. We have a dev team, production team or admin team, and a partner team. So the dev team was able to deploy pods within certain quotas. We did not allow them to exceed CPU or memory quotas across all their virtual clusters. Prod team, they are the lucky ones. They have an unlimited access. They can starve host cluster if they want to. Partner team were able to only deploy pods with certain tolerations, meaning that the pods that they would deploy would be deployed only to a specific nodes that virtual cluster targets. So we already from the get-go, we said even your pods, you can deploy them, but they're gonna land on a special fortified node. And we have also other ways within our product portfolio to make this security setting even tighter using products like vNode or other things. Services, our dev team was able to use only cluster IP services. Prod team, again, those guys can do whatever they want. And partner team couldn't deploy any services. If they would try to, they can deploy them, of course, inside the virtual cluster, but they cannot synchronize services between host cluster and virtual cluster. Same for ingresses. Dev team couldn't use it, prod team could, and partner team were not able to use it. Nodes, config maps, and resource limits. So as far as the sliders go, you can imagine that now fourth team comes in and the team, are you guys can hear me well? I'm not sure if my voice
We can
output.
hear you fine. You're just sounds
perfect.
like your audio is starting to go. That's all.
Yeah, 98% CPU. You can see that my machine needs an upgrade. All right, so real quick, we have this fine-grained control over what crosses the boundary of virtual cluster and host cluster, right? And if you apply this to tens of tenants, cool. Hundreds of tenants, super cool. Thousands of tenants, but now we're talking, right? You have ability to use infrastructure as code and GitOps to have your virtual clusters being deployed and managed to those tools. Remember, those are just Kubernetes pods at the end. And we also have a product called a vCluster platform, which enables you to manage your virtual clusters additionally at scale. I haven't talked about a lot of features that we also support. For instance, you can put virtual cluster into resources to sleep. If a team in different time zone finishes work, you can set hours where you save resources. So This gives us a way to bin pack as much resources as we can within a single cluster. So what can we see? We have those 3 virtual clusters running: dev team, partner team, and prod team. They are all running vCluster version 0.30.3. And now this is the namespaces where they run on. So really quickly, just to go over the benefits one more time. Our customers use vCluster in dev test environments. This was the original use case before we added more isolation. You can use it at GitHub CI. We use it to test in QA instead of creating clusters or using predefined cluster, which is create virtual clusters within our main host cluster and delete them afterwards. And this works really well. Tenant isolation, as we've seen, the sliders, I hope that kind of drove a point home that you can fit not only your current use cases, but also future use cases. If one team starts at one spectrum, they can gradually move to more secure or less secure or shared services and so on. Independent versioning, this is honestly my favorite. I know I'm boring probably, but I've done my share of updates and upgrades in Kubernetes, and the more the more tenants you support, the more stressful it becomes. Whereas with vCluster, you can choose to have shared services distributed independently, and then you can version each tenant independent. You can have a very small blast radius. You can test it on virtual cluster. So this is really fantastic feature, and kind of helps SRE not have too much gray hair too early. Platform efficiency, mentioned about sleep earlier. There are also other features. A lot of them are obviously enterprise, but you can essentially save a lot of cost or support like high scale within the cluster itself. And finally, security boundaries. If you want to fortify your cluster, we have additional products such as vNode or other ways to kind of lock the isolation even more. So you can essentially choose to go from namespaces with very weak isolation to almost complete host clusters, but not quite. So you can have your own dedicated nodes for each virtual cluster. So we support this as well. You can visit our page, our docs, and learn all about it. So that's it. If we have time for any questions, we'll be happy to answer.